G'day, it's Jerry again. I've got this USB portable rechargeable soldering iron that I bought off AliExpress for, I think it was 14 Australian dollars. Today I thought I would have a look at it. It says here, first gear, 330 to 360 degrees centigrade, then 370 to 400, 420 to 450. Let's have a look on the back. It says the battery capacity is 800 milliamp hours. Continuous usage time approximately 20 minutes at the highest temperature setting. Maximum temperature 450 degrees Celsius. The charging time is 90 minutes. Charging voltage is 5 volts. Cycle usage count 500 times. So I guess basically the internal battery will wear out after 500 times of use, which is all helpful information. Let's see what we got inside. Okay. It's got a nice case, and that's really important when you buy cheap tools and things like that. They often come with no case or the crappiest case you could imagine. This actually looks fairly decent. This looks like it could actually last with a bit of use. It's actually got proper hinges and everything on it. Look at that. That's really very, very nice. So we've got some more instructions. And it looks like it comes with everything, which is really good. We've got some solder there. What's this? We've got a little soldering station, little stand, which you need, right? We have got a USB-C charging port. We've actually got some rosin, which I've never used it, but you know, it's hard. It's the actual hard rosin rather than liquid flux. But once again, useful. And we have the unit ourselves. So this tray here is a little bit crappy, but perfectly adequate for the job, considering that the case itself is quite nice and protective. And here we've got our soldering chip and our USB charger. Well, it feels okay. You know, sometimes you get cheap things made of plastic and the plastic feels so cheap it makes you want to shudder. This is cheap plastic, but it's not as cheap as it could be. So, you know, I'm not going to complain about that. So, comes with a very fine tipped end on it. So this is not meant for soldering really large components and things like that. And how does that go in there? Surely it doesn't just push in. It actually feels as though it does. So no locking. You just shove it in. I mean, it's in there solidly. I've never used these type of tips on any soldering iron. You just push it in. Click. Okay. So how do you turn it on? Hold a button. If I just hold it down, it flashes. If I press it once, twice, 3 times, 4th time, it turns off. Oh yeah, that's all it is. Alright, it's unfair to this to not actually charge it first. So I guess that's what we need to do next. I've got a USB-C. And is there any indicator? Oh yes, there is a tiny little LED indicator down here to indicate that it's been charged. Charging time 90 minutes. Okay, so we'll give it 90 minutes to charge up. And maybe this will go to green or something like that when it is fully charged. And what we're going to be doing is I thought I would actually try building a kit. I have this kit. I think this kit is a clock. I've had it forever. It's all through hole stuff, and it does have some quite thick components with legs on it. So if I can manage this, I'd be very impressed. I recently met a guy. He's a bit older than me. He had grandchildren. He said that he bought a bunch of kits and a soldering iron and got his grandson hooked on electronics. And I think what a great present this could make, because this was 14 Australian dollars. These kits you can buy off AliExpress for $2 each. $20. What do you get for $20? Not something cool and educational like this. So that's what I'm going to keep in mind. Having said that, I do like the idea of having a portable soldering iron. Okay, so it's been a bit longer than 90 minutes, but I've come back and there is indeed a green LED to indicate it's fully charged. Excellent. So I do wonder whether if this wasn't fully charged or it had no power and it was powered by USB, would it actually work? That's something we're going to have to test. But first, let's use it on battery power. I do like building kits. I find it very therapeutic. Let's just see what we've got here. It's been so long since I purchased this. I have no idea. Like I said, I think that it's a clock. There probably won't be instructions. Well, there's quite a lot of components. Yeah. So that's what it looks like. It's got... So there is a website and a part number. Maybe that will lead us to the instructions. But normally you can build kits like these without resorting to instructions because everything's marked on the PCB. So this should be quite a challenge, I think, for this little soldering iron because, some of these components here, have pins that will require a decent soldering iron to solder. So there we go. So what I'll do is I will fast forward through the boring bits, the repetitive bits, but I'll talk you through parts of it. If you don't want to hear me prattle on about stuff, look in the description. There'll be links where you can just jump ahead to the different sections of the video. So the way that I generally put these together is you do the lowest, physically the lowest components first, so they don't get in the way of the other things that you're going to be doing. So the lowest components in height, probably going to be these resistors here. I'll zoom in and hopefully you can see that maybe the resistors, which are numbered, R7, R6 and all that, they actually have the value on them, 1K. So there's a bank of 1K resistors here, 1K there, 1K there, 1K there. Are they all 1Ks? 1K, 5.1K just here. So to figure out what value the resistors are, you can look at the color codes on them. Or you can cheat. So these are all joined together, so these are all going to be the same value, and these are brown, black, red. So they'll be the 1K, I believe. I think it's brown is 1, black is 0, and red is the number of zeros, the multiplier. But another way of doing it is just to measure it with a multimeter. Right, so I've got my multimeter and I've got it set to ohms. So you can see that. And we can just touch the leads and we're getting 1K, 1.003. So we know these are the 1K resistors, and we can just do the same with all the other ones. Now, another device that you can use, which is really, really handy, is this thing. This is called a component tester. And basically it will test components, and it'll tell you what they are and what their value is. And it can be really useful if you're actually repairing something and you take out a resistor or a transistor or something like that, and you don't even know whether it's any good and you want to test whether or not it's actually working. Yeah, okay, so you just put it down into any of the holes in this thing. I've got a switch on mine which I put in there to stop the battery going low. This is quite an old version, so it's just testing to make sure that this device is working. The battery's got enough juice in it to run this screen, and it's saying it is a resistor and its resistance is 1005 ohms. How cool is that? And so you can do that for basically any component, even a transistor or something like that. And there you go. So it's a PNP resistor. And it actually gives you a whole bunch of information about it. Fantastic device. Everybody should have one of these things. They don't cost a lot of money. This is quite old. There's much newer models. Fantastic too. Like I said, if you're repairing things and you pull a component off a board and you don't know whether or not the component is any good, then this device will come in very handy. All right, enough of that. So I'm going to populate the board here with all of these 1K resistors, and then let's crank up this soldering iron. Okay, so I'm just going to stop there and use a soldering iron because I'm too excited about this to not do it. Ah, there's something else. I bought a board holder as well when I bought this soldering iron. Let me find that and see if that's going to help us out. Okay, check this out. So PCB fixture. So this is a magnetic holder for PCBs. I've never had one of these before, so I have no idea whether the concept even works. And the reason that I haven't had one before is because they're always expensive, even on AliExpress. These are expensive. I guess it's because they've got to be machined, and that's a big solid piece of metal. But basically, these things have little grooves on them that you're able to position to hold your board. Okay, so we want our board like this. So I have no idea. So you can stick like that. Yeah, and that's holding the board in place. Now I like to, So it'll come at these things from this angle, I think, and to stop it sliding around. That's why you need the extra one, see? Now it's completely trapped. Cool. Okay, so I think perhaps we shall try and use the solder that came with it, just for a bit of fun. So we'll turn on the soldering iron on to its lowest setting. So what is its lowest setting? 330 to 360 is its lowest setting. And then we'll just try it out and see what goes on. You know, and then we'll move on to 370 to 400, 420 to 450, and just see. So how do you know when it's reached temperature? Well, we'll definitely know if we try and melt some solder and it melts. So we can just touch the tip to it and see what happens. Oh, wow. That started up already. Got up to temperature already. That's fast. Well, let's just see. Nope. Oh, and there's the first problem is I accidentally pressed the button when I held it, because you know I need to hold it at a certain angle, so I've accidentally pressed the button and we've gone to the second setting. So you have to be careful how you pick it up and how you hold it. Okay. That is definitely melting that solder, but it also has to overcome the thermal mass when you touch it to the actual board. Did that work? Oh, and I've just done it again. I've just pressed. Right. Well, I don't think that was going so great anyway, so let's crank up. Wow, okay. Actually worked. I have no idea how good this solder is. So there's two that I've done. Now, yeah, I don't know if you can see that. So it's having no problem. Now I've got to be careful. I don't know why I keep wanting to touch exactly where the button is. And this is having no problems whatsoever soldering. I'm having trouble seeing. It's my biggest problem. Okay. So we have no liquid in our little spongy thing here. I hate the sponges anyway. If you ever want to do any soldering, get yourself some of this. It's just like copper scraps in a tin, and away you go. Yeah, I'm struggling a little bit there. I think I'm going to use some of my own solder. So I've really got something to compare it with. So this is leaded solder. It's about, oh, maybe it's even thicker than that stuff. So this is what I would normally use. Oh, and that's much better. Yeah. Absolutely no problems whatsoever. Just touch that one up. Okay, I'll just turn that off for the moment while I have a look, see how we've gone. Yep, that one pushed up a little bit too far, but that's okay. I wasn't being terribly careful. So absolutely no problems whatsoever. The soldering iron works. Right, I'm just going to go ahead and populate all of the resistors on this board. Okay, well that's all the 1K resistors done. This thing works great. And it's incredibly quick to heat up as well. I reckon it only takes 10 seconds to go from cold to full temperature. And something else I've just realized is that because the tip just pulls in and out, you can just replace it. Like if you have, I've only got one tip, but I could easily replace it with another tip. You know, if I had a chisel tip or something like that, it would be so quick. That's really incredible because, you know, with my normal soldering iron, it takes forever to cool down. And then I've got to unscrew this whole thing, you know, remove that, put a new tip in, put it back on, and basically I have to wait for this whole thing to cool down before I can do that. So it takes 3, 4, 5 minutes to change to a different tip. It's a real pain in the ass. Whereas this, it's so easy. I forget what this tip is called. I'll look it up. I put a thing there, a T10 or a T12 or something like that. So it's not unique to this particular soldering iron. It's a different style of tip for soldering. And I'm just blown away by it. I now am looking at my old soldering station and going, I don't want that anymore. I want one with one of these tips in it. Amazing. So far, this thing is performing fantastically. All the resistors are on. Okay, so we might do the diode next. The diode has leads that are a little bit thicker, not terribly much thicker than the resistor, but nonetheless. Afraid my hands are a bit shaky today with too much coffee. Plus I've always been a bit shaky. Okay, so what's next? I think I might do the transistors because they're all situated in the middle there. I'm trying to conserve as much energy as possible by turning it off in between doing these things. It's really whether or not the soldering iron can cope with, you know, the larger components that I'm interested in, you know, like the legs on this, sorry, the legs on this button are a bit thicker than, oh. Did I turn that off? Ah, no, it's turned itself off. So I guess we are out of juice. Is that right? Yeah, I'm guessing that's what it means. Okay, this is an opportunity to see whether or not it will solder if you have the USB cable plugged into it. Because some devices, they won't function if it's charging at the same time. And that looks to be the case. Is that right? Keeps turning itself off. And we're charging. Okay, so that's a little bit disappointing, but I'm not really surprised by that. So we will have to let this recharge. So, I mean, this is how much it's got soldered on one charge. So, you know, reasonable. All right, well, I think it takes something like 90 minutes to fully charge up. So we'll come back a bit later. Okay, well, I think I might just put all the rest of this back together. All the components, the rest of the components, and I'll come back when we get to components that have thicker leads, and we'll see how well the soldering iron works on those. Okay, so we're back. These are the pins for the buttons, the tactile push buttons. So I'm just going to show you soldering those because they've got a slightly bigger surface area, but the soldering iron has absolutely no problem with that. Beautiful. Okay, I just realized that I wasn't recording then, but I'm soldering on the IC socket and there's no problem doing that. It does take a little longer on each pin than the others because the pin does have, these pins are thicker and they have more thermal mass. But the soldering iron is having no problems whatsoever in soldering on that IC socket. Just got to take it a little bit slower. So it is only an 8-watt soldering iron if it's, you know, if that's a genuine figure. Did I accidentally turn that off? And no, it's telling me that it's run out of batteries again. Well, that's interesting. I didn't feel like I got as much soldering done then as I did the first time. Oh well, I guess we just need to charge it up. We'll come back to that when it's fully charged again. And I just tried to use the solder that came with this again, and I couldn't get it to work. I don't know what it is. This is 6040 leaded solder, the stuff that I'm using. So yeah, probably if you buy one of these, I would get rid of the solder and wrap your own solder around it. I do like the fact that there is, you know, something that you can store solder on. All right, well, let's just wait for this to recharge. Okay, let's get these last pins. Okay, and then there was the oscillator. It's down here. Looks pretty good. Okay, so why don't we move on to these guys? So is there any difference between them? I don't think so. Just want to have the dots down the bottom. Okay. Same deal. Just do a couple of... Is this still on? I'm going to turn it off. Turned it off. But anyway, let's try this because this is where the pins that I thought might be the biggest problem for it. Because they are long and they are thick-ish. And so it needs to have enough juice to overcome the thermal mass, which it does. I think it's just a matter of holding it on for a little bit longer. Let me just check and see what those look like. Yeah, they're fine. It's not great, but that's more to do with my soldering than the unit. And this one is definitely sitting up too proud. So I'll just get a hold of that, pushing down. Still. I'll just heat up each one of these pins and give them a firm push down to make sure they're all sitting flat. Yeah, they're all just a little bit up. I think I would have preferred a chisel tip with this unit. Oh, and now I've just accidentally turned it off again. Okay, so this soldering iron's having absolutely no problem with any of the components that are on here. So there's not much left. I think there is capacitor, the piezo. Yes, I'm calling it piezo. Deal with it. That, and looks like we're supposed to power it from a LiPo. Maybe that looks like the end for a LiPo battery. Anyway, we'll figure that out. So I'll go ahead and finish this off. And yeah, we'll see if we can't get the circuit to run. And then we'll do a teardown of this, and I'll tell you my final thoughts. Okay, so the circuit is complete, fully soldered. I've got a 9-volt battery connected with a little switch that I found. Let me turn it on and show you. Now, as you can see, one of the digits here is not lighting up. I don't know what that is all about. But I intend to make a completely different video about this kit, including going through the schematic and trying to figure out how it works, and also use my new Aneng multimeter oscilloscope, which I bought in another video, which I'll leave a link to if you want to have a look at that. I bought a number of Aneng devices. I'm going to use that to go through the circuit and see if I can't figure out exactly how it's all working. But for the moment, this is all about our little USB soldering iron. Now, unfortunately, it no longer works. So I've probably recharged this 5 times maximum, and when it ran out the last time and I tried to charge it, nothing happened. It wouldn't light up at all. So that's very disappointing. So I think the documentation said it was good for 300 charges, and we only got 5. So it's time to tear it down and have a look and see what's inside. Not very much, I would imagine, and perhaps we can even figure out why it's no longer working. I'm going to have a guess and say that the battery is faulty and it's not accepting charge. But who knows? So you might as well play the lottery and have a think for yourself what might be wrong with it. Put it in the comments if you want, and then we will see together exactly what is inside this to go wrong. All right. So it appears to just have one screw here for us to undo. I feel like these ends should pull off, and that allows the thing to fall open. It's always possible that it's glued. All right, I might try and get a spudger in here and see what happens if we give it a little bit of a tweak. Oh, it certainly got in there. But as I thought, these end caps here are going to be holding it on. I don't know whether they're glued or not. So I'll just try giving them a twist. No. Doesn't appear to be anything else going on. So we might have to brute force this. I don't think we're going to be getting this thing back together after we get it apart. No way, Jose. Okay, I'm going to go and find some pliers. Okay, look away, children. This is not going to be pretty. And there it comes. And what can I see? Yeah, glue. So it's just been glued. So yeah, it requires force to get that sucker off. And there's a couple of screws under there that's keeping that USB-C board in there. Okay. But we still won't be able to pull it apart. It'll still be needing for the same thing to happen to this end. Got it. Whew. Ah, and there's 2 screws in that end as well. So, yeah. I mean, wasn't pretty, but I could probably get that back together. Although, I'll be honest with you, even if I could fix this, I really don't think I have much use for this unit. With its limited battery life and 90-minute recharge time. But I guess we'll get to that in my final summation after we've had a look inside. Oops. Oh, that screw's Gonski. Okay. So there we go. So what have we got? We've got our lithium battery here. Our, I don't know, what are they, 18650 battery. And that is actually just, you know, sitting in a spring-loaded little pocket there, which is great. I mean, that's a really nice design. I think that this battery is going to be flat, indicating that either the battery is dead or the charging circuitry hasn't been charging it. Yep, so I've got that around the wrong way, but yeah, 0.068 of a volt. That is one dead battery. Yeah, I wonder if I've got a battery that size. That's shorter than what, yeah, sorry, that's out of shot. I wonder if I've got a battery that size because, you know, that's shorter, I think, than any of the ones that I've got. It'd be interesting to see whether or not if I put a brand new one in there, if it would work. But let's have a look around. So our our button, sorry, is just a piece of plastic. And we've got 2 buttons. So we just got a board there with 2 buttons on it. So this metal bit here is just to allow the tip to sit in it away from the plastic so it doesn't burn the plastic. It's not actually doing anything. And here's what's doing all the work. Now I wonder, is it possible for something to have gone wrong with the wires? The wires have come out? Not sure. Let's see if we can get this circuit board out. Oh, there are 2 screws there as well. Okay, so we've got a chip with a little bit of circuitry on there, which I'm guessing is the charging circuit. We've got your LEDs. There's a separate USB-C charging board down here. And that's it. I might as well just take out this little USB charging thing as well. Take a look at that and see whether or not there's anything going on there. Let me just put my little... So the chip on that is marked 4057317. Looking at all the components, none of them are shorted or blown up. So there you go. That's the entire circuit in all its glory. Why don't I get the microscope down there and see, you can have a look a bit closer at that chip. Okay, so as you can see, there are no markings on that chip. It's just a black chip. There's some resistors, capacitors. Looks like that's perhaps a transistor there. Turn the power on. And, you know, everything goes up to here. I don't know what I was expecting, but perhaps more than that. Let me flip this thing over. I'll just bring it down here again. So there's the, well, if you go all the way down here, you can see there's the USB charger. It has its own little charging port there. Everything still seems to be connected. You've got your buttons, and then you've just got these 2 essentially rings. So here's the end of the soldering iron. Yeah, and it just sits in there. It's just friction fitted in. They're just providing power into the tip here. And however this tip works, that's heating up. Yeah, okay, that makes sense. So there we go, not much to it. In actual fact, I'm looking at this and I'm wondering, is this just a very large vapor circuit? I mean, is this what, you know, are in vape cigarettes and things like that? Have they just repurposed the technology out of vape devices and made a soldering iron? Anyway, that's it. That's all she wrote. So what's wrong with it? I think this battery is dead. So it's either that the USB circuit, charging circuit, is failing to charge its battery, or this battery is just dodgy. So I wonder if I had a charger that could attempt to charge this. The problem is it's not as long as 18650 batteries that I have, if they're even called 18650 batteries, because I think 18650 describes the width and the length of it. So maybe this is an 18640 or something like that. I'm not 100% sure how it works, but I don't think that I have any batteries or chargers that would be of the right size to fit this. Otherwise, I could put another battery in there and see if it charges up. Or I could take this battery and put it in another charger and see whether or not, you know, what part of it is broken. Well, let me have a bit of a root around in my battery collection and see if I haven't got something. Yeah, so I found this battery here. This is an 18350. So like I said, I don't know, it describes the size of the battery. So it's a, it's a lithium ion battery. But, this is the charger that I've got. And it actually says 18650, so that's the size of an 18650 battery. Unfortunately, I'm not going to be able to try and charge that to see if that was the problem. Alright, so I thought perhaps we should just have a look and see if we can't figure out a little bit more about what's going wrong with this soldering iron. I've put the battery, which we know is absolutely dead, back in here, and I've got an ammeter here, and I just want to see what happens if I plug it in to the USB charging port. See what it does. So it's fluctuating a little bit there, so 0.028, 0.032 of an amp. So I guess that's, 28 milliamps, 32 milliamps, and it seems to be cycling back and forth. I don't know whether that's the correct behavior, whether it's detecting that, it's attempting to detect whether there's a battery in there or not. Maybe we can just have a bit of a poke around at the same time, voltage wise, and have a look to see what's going on here. So I think that these two here are the... Okay, so it's sort of cycling. I don't know if that's normal for this charging circuit, whether that's what it needs to do to detect whether or not there is a battery there and whether it should give it more current. I was looking through my box of batteries and I found a real 18650. So basically it's the same type of battery, but it's much larger in size. So I haven't checked. It's got 2.38 volts on it. So what I was wondering is maybe we could do a dodgy and solder this onto the terminals and see whether or not it attempts to charge this battery. And if it does, then that indicates that the charging circuit is actually working. Another thing I'd like to try is to figure out whether or not, we could bodge some wires to try and make this thing work just plugged into a USB cable. I imagine that's fraught with all sorts of danger, which is why the unit doesn't work that way. But hey, I'm just soldering some wires onto this battery terminal. I don't suggest you do that. I'm a bit worried about exploding, but I just found another great use for this little board because it can hold that up right, because my normal helping hands won't fit around the battery. So that's pretty cool. So I'm just applying a lot of flux. And hoping and praying that this battery doesn't explode, because the solder really doesn't want to stick to it. I really don't want to turn it up too much. The other side had the leftover tab that was spot welded onto it. Wonder what would happen if I roughened that up a little bit with some sandpaper. Oh, that can come off. I've never done this before, so I have no idea what's going to work. And I need some more solder. Wish me luck. It's managing to get a little bit of solder on there. Yes. Okay. Right. Whew. I have no idea whether or not it would explode. I just don't think it's a great idea to solder things directly onto these. But anyway, we've managed it. There we go. So, doesn't feel too hot. So this is definitely the negative end. There's a little negative mark there. That's the only thing that indicates with this battery, because it came out of something. Didn't come from the manufacturer. I pulled it out of... Oh, I've got no idea. Okay, so now in theory, if we were to connect these wires onto these 2 points here, see whether it tries to charge this battery. All right, that's all a bit dodgy, brothers, but there we go. So we've got a reasonable lithium battery cell in there. All we have to do is plug it in. Plug in the ammeter and see what happens. Okay, so let me just check this, that it's all connected correctly. Oops. Get that in shot. .3. This is quite a sophisticated ammeter. Even has graphs and things like that. So we've still got it cycling between 0.02, 0.03 of an amp. So I guess the difference is we know this is a good battery, so is it just going to keep cycling like that? Is that part of the startup sequence until it feels that the battery is absorbing some of the charge, and then it ramps it up? I guess we shall just have to leave that for a little while and see if it changes. I won't be leaving the room. I don't trust any of this. But we'll come back in a while and see if anything has changed. Okay, so it's been 28 minutes, almost half an hour, and nothing's really changed as far as charging is concerned. Okay, so maybe it is the charging board that has caused the problem. Well, something else we can try, since we're already here, is I have a little charging board circuit for one of these batteries. So why don't we wire the battery up to that and see whether or not it charges as an experiment. Okay, so the cabling's getting a bit messy now, but let's just plug this in and see what happens. Okay, so immediately it goes to 0.1 of an amp through this charging circuit. So I think that's 100 milliamps. Got a red light indicating that it's not fully charged. All right, so I guess what we should do is just leave this battery charging and see how this changes and whether the voltage in this increases. But it's definitely behaving completely differently connected to this charging circuit than to this one. So that makes me think that perhaps the problem was with this USB-C charging circuit. But we'll wait and see. I'll start another timer. We'll give it half an hour and see what goes on. Okay, well, it's only been a minute or so and it's already jumped up to 1.1 amp charging. So yeah, it's definitely liking this battery and charging it. Might as well just see what this charger is outputting to the battery. Three point seven five. And it's maxed out at 1 amp. So I think the battery is fully charged when it gets to 3.7 volts. Okay, it's been a few hours now and it's now down to 0 amps charging. I came over every now and again over like a 2 or 3 hour period and had a look, and the amps were slowly going down as the battery was being charged. So now it's fully charged. So let's see what the voltage is, fully charged. 4.15. I think the next step is to put this battery back in circuit with this and see what happens now. So my understanding of these charging circuits is that they do the intelligent charging, so they provide more current when the battery is empty and slowly provide less current until the battery is completely charged. Then they stop charging. And also they prevent the battery from being discharged when it goes below a certain point. So either this battery, the one that came with it, which is now at 0 volts, either there was something wrong with it, or this circuit over here allowed the battery to be completely discharged. And I'm assuming that this actually works. I'll plug the tip in and we'll see if it heats up in a second, but it powers on and does all that sort of stuff. So I guess what we could do is we could take this charging circuit and we could try and charge this battery. We could get this battery to discharge. Actually, we could discharge this battery and see whether or not it stops at the correct voltage level. So it turns itself off, essentially, leaving enough charge left in the battery to stop it going to 0. And we could also try and recharge this battery from this charging circuit. I guess we could try and charge this battery. It's at 0 and like it might charge up, but I don't know, you have to be a bit careful about charging batteries from 0 volts because, you know, they can blow up, they can cause a fire, stuff like that. So I'm a little bit hinky about doing that. But I think we should definitely start discharging this battery through this, make sure this all works. Prop this up. I know it looks a bit dodgy. Well, it is dodgy, but I'm not going to leave this alone. And this is a much larger battery, so technically it should take longer to discharge. Let's see if it turns on. Let us just leave it running like that and run down the battery. All right, so it's at 3.9. Let's see what happens. I'll leave this running. I'm not going to leave the room. And we'll see how long it lasts. This battery, the condition of this battery, I have no idea. Okay, so that didn't take very long. 10 minutes on the dot. Let's check the voltage. 4 volts. So there you go. So according to the internet, 4.2 is the minimum safe charge. So it's gone a little bit beyond that, but not too much. So I guess the other thing is it possible that it's going to keep discharging? Is there something in this circuit that is consuming power, and if you leave it long enough, turned off? So it's at 4.008. Okay, so I think what we'll do is we'll just leave it like this, and we will see whether or not just having the unit unplugged is continuing to draw power from the battery. So it's been a few hours. I'm just going to recheck the voltage of this battery. And yeah, it's still on 4 volts. Wasn't really thinking that it was draining the battery while it was in this low power mode, but I thought I'd just give it a try. I don't really want to leave it much longer, because I think what we really want to see now that we have a good known good battery in here is whether or not it will charge using the original charging circuit. So why don't we bring that back in and see what happens. It appears to be doing exactly the same thing as it was doing last time, just fluctuating at very low milliamps. So yeah, it's got a faulty USB charging circuit on it. Seems to be the fault. Well, one of the faults. Interesting. I'll leave it there for 20 minutes and we'll see whether it goes up, but I'm almost 100% sure that it's not going to attempt to charge. Okay, so it's been half an hour. There's no change to the way that this is working. So I think we can stop that. So what do I want to do now? Well, I think what I want to do is recharge this cell up here. There's a couple of things that I want to try out. One is I would like to see what the voltage is at the point where the tip goes in. Just out of curiosity, does this chip that's on it boost up the voltage to, I don't know, 12 volts or 20 volts or 30 volts or something like that in order to make this cartridge tip work? Or does it simply pass through the 4 volts or something like that, 4.3 volts to the cartridge, and it just heats up under low voltage? So once I've satisfied my curiosity about that, then I would like to see what happens if you just inject 5 volts. And I know that this battery, it's 5 volts here, but it's not charging the battery at 5 volts. But I'm just curious to see if we put this on the variable power supply and crank up the voltage here, whether or not we can get this to run without the battery and without the charging circuit. Because, potentially we could run it from a USB power bank. Probably burst into flames, but I'm just curious to see whether that would be possible. Okay, so I've got some charge in this battery. It's not fully charged yet, but I don't need it to be fully charged. Just enough juice so that it will actually work the soldering iron. So that's 4.1. I think that should be enough. So what I'm going to do now is just solder it back on. So what I'm curious about is what is the voltage that it's supplying to the tip. And I'm assuming, so I'll put this into continuity mode, that one of these rings is going to be the voltage and one is going to be the earth. So let's just see if that's true. Yeah, so the top one is connected to earth. So let's put this back here. So the idea is I want to measure the voltage there if it turns on. So hopefully there's enough charge in that battery to get it to start up. So that's no. Need to charge it a bit more. Okay, I've recharged this battery. It's now sitting at 4.15 volts. And we're going to attach it back into the soldering iron. Right. Well, now it's not turning on. So have I done something wrong? Well, why don't we disconnect the USB circuit board. We'll leave the earth connected. Maybe we'll just try that. So we'll just keep that. So now we're just charging it directly from this battery. Right, so now it's not doing anything. So this must be communicating with this USB charging port. Oops. Oh, that ain't good. So I just shorted it out. Well, at least we know it lights up. Don't leave. Oh, do it again. Yeah. So I think she's completely kaput now. If she wasn't before, yeah, that was not good for it. Gave me a bit of a fright. Yeah, so definitely, this chip is communicating with this USB controller. So I'm not really sure what I did the first time to make it work. Well, that was just pure luck. Let's see what happens if I press the button now. Yeah. So yes, it's not happy to start up. Yeah, so we did get that external battery to operate this one time. Yeah, so I just checked the video just to see that the voltage was the same. So it was 4.15 that we got it to turn on with the external battery, and this is 4.135. So the battery's charged enough that it should run, but it doesn't. So when we press the button, instead of turning on, it gives us this flashing that indicates that there isn't enough voltage. Well, that's one of the reasons why it flashes. I'll just put the tip back in just to make sure. Yeah, so it looks as though we've lost our chance to test the voltage at this end. And we definitely know that this board is talking to this board, because if I disconnect the red wire, it's not happy. Yeah, I've blown it up. There's a little scorch mark on the chip. It's tiny, I won't be able to show it to you, but there's definitely a scorch mark there. So this is now kaput, and there's nothing more I can do with this. Well, it's been fun anyway. It's been fun to play around with. I just wish that I had checked the voltage on there, because I'm just curious to see whether or not it's low voltage. We've got a dead battery here, but we've also got this charging circuit which would not charge this battery. So I suspect that this charging board probably went haywire and it completely drained this battery. So now we've got a dead battery at 0 volts. And unfortunately, the rest of the circuit needs to communicate with this charger in order to operate. So that's it. So I was just thinking, even though this circuit is no longer working, there's no reason we can't apply our own power to this tip and see what sort of power it needs to heat up, because I don't think there's anything wrong with this. I've got a variable power supply, and it might be worth doing that just for fun. I don't know if it matters, but it should figure out which end is earth. So this spring over here is negative. So I've got this in continuity. Okay, so it's the front bit that is negative and the back that's positive. So let me turn on my variable power supply. I have absolutely no idea how much voltage is being put into this tip, whether or not it's just the 4.3 volts from the battery, or it's been stepped up to larger voltages via this chip here. That's all right, we'll soon figure this out. So we said the front part was the earth. I can't find my thermometer to test the temperature at the end. I don't think that using a thermometer or anything like that is accurate anyway. I saw a video from Big Clive where he tried different mechanisms to measure the tip of a soldering iron, and you couldn't really do it with any sense of accuracy. You need a special little gadget, some sort of device where it has crisscrossed wires, and you put the tip of the soldering iron in the middle. But that's okay. Really, we can start off with finding at what voltage it starts melting solder. That would be my first test. Okay, so I've got my variable power supply set up for 5 amps maximum and 1.5 volts. So if I connect this up, just trying to keep everything in line, we should see what happens. So the amperage has gone to 0.64 of an amp. So it's drawing 640 milliamps off a 1.5 volt power supply. And we'll just give it time to heat up. And no, that's not quite enough. So let's crank it up. So I've gone to 1.8 volts and it's now drawing 0.77 of an amp. So 770 milliamps. Nope. Okay. So let me bump it up to, I've got it at 2.2 volts. It's now drawing 0.91 of an amp. Okay, it's still not enough. I'm going to crank it up to 2.5 volts, and it's drawing 1 amp at 2.5 volts. And still nothing. Okay, so let's go up a little bit. So it's now at 2.8 volts and it's drawing 1.15 amps. Oh, and it's just beginning to melt. So that's yeah, so it's struggling a little bit to do it, but it is doing it. So that's at 2.8 volts. It's drawing 1.15 amps. So let's crank it up to 3 volts. So at 3 volts, it's drawing 1.21 amps. Yep. And now it's not really having any problems whatsoever. Let's crank her up a bit further. 3.4 volts. It's drawing 1.4 amps. And that's no problems whatsoever. You can feed as much solder as you want into that sucker. No problems whatsoever. So power is voltage times current. So if we've currently got 3.4 volts times 1.42 amps, the amount of watts is almost 5 watts. And this is an 8-watt soldering iron. Well, that's what they say. So it seems to be melting quite nicely at 4.8 watts. So why don't we crank it up and see if we can't get to something close to 8. So 4.2 is the maximum voltage of the lithium battery that was in there. So why don't we just crank it up to 4.2 and see what happens. So we're at 4.2 volts and it's drawing 1.67 amps. So 4.2 times 1.68 actually gives us 7 watts. And of course, that is really melting now. So is it really 8 watts? I'm not really sure. I mean, who knows? But definitely a fully charged lithium battery at 4.2 volts is drawing 1.68 amps, and that's giving us 7 watts. So I'm trying to, I'm learning electronics, so I'm trying to actually do the calculations to see if they make sense. So, it's possible that this is increasing the voltage. I'm not really sure, but they're the figures that I'm getting. So that's very interesting. This gadget has no place in my tool chest. It was good to use it, but the trouble is that if it takes 90 minutes to charge and it only lasts a maximum of 20 minutes, that's really not enough time to do anything. And I really don't see the purpose of this device. If it were to run off the USB cable when the battery was flat, then I could totally see that this would be great, because you could use a USB power bank and you could plug the USB cable into it. And in actual fact, having used this and seeing how great these tips are, that's what I'm going to do. I'm going to go out and find myself a better quality unit that will run off a USB power bank or something like that. That's really what would be useful. That's what I could take out into the field. If, you know, I can always have a power bank with me. I don't want to be taking this out and finding out that I need to charge it. I don't have to charge it from my USB power bank anyway. So yeah, I just don't see the point in this product. Okay, so just a quick reminder before I leave, I'm going to make a completely different video about this clock circuit because I really like it, and I want to examine the schematic for it and see if I can't figure out, because I'm learning electronics, can't figure out exactly how it works. So keep an eye open for that video. All right, I guess we'll leave the video there. So if you've enjoyed it, please think about subscribing to my channel, giving me a thumbs up, leaving a comment, anything like that, and check out some of my other videos. All my videos are classified into playlists, so you might find a playlist that suits you. Otherwise, I'll catch you on the next video. Ciao.